So as I move on to recapping the power supply, there are two things I have to do. And one thing I want to talk about, get a little scratch pad here. I thought I may have had some caps that I could throw in for the filter caps. These are 4700. Yeah, I think so. Kind of the general rule is 30 to 50% increase on the filter caps. So these are 47s. I have, let's see, what are these? 82s. I just think these are probably going to be a little too big to go in there. I mean, they fit size-wise, physical size, but I think the capacitance might be a little bit too much. So the issue that you can run into with these is, you know, when this thing powers on, you know, when you have it on a dim bulb and the light flashes and then it goes dim, that's because, you know, the filter caps, among other things, are charging up. And it's not so much an issue of the capacitance of the filter caps in terms of the operation of the receiver, but if these are too large, you can stress the components in the power supply, like the rectifier, and you could end up causing some damage. So, you know, a general rule, at least what I've seen, is a 30 to 50% increase. So just using whole numbers, if these were 4,000, right, you'd want to put 5,000 to 6,000 microfarad caps in place of these, right? You wouldn't want to put 8,000. Now with 47, I'd have to do the math. I still think 82 is probably too big to put in there, but, and I'm going to take you through the process anyway of, okay, assuming these don't fit, and again, it's early in the morning and my brain is not wired to do math at this point in time. So I'm going to measure these to figure out, so these are 30, this is 36, these are 35, so I'm going to put 35 millimeter, and I think it's 36 because it has like a plastic cover on it. And then in terms of height, I'm just going to eyeball this, figure out roughly how tall these are. Again, I'm not trying to be exact, but they need to be less than about, let's see, what is that? About 70, 75? So less than 75. So anyway, I'm either going to, I'll have to do the math on these and really think about, I think these would be too large though. Think about putting those in those spots. But I'll let you know what I determine when I work through that. Now, if you can see that this power supply board is, well, actually, I didn't show you the bottom. So it's completely accessible from the bottom. All right. So it's completely accessible once this board here is loosened and removed. So I'm going to, I'm not going to remove the power supply board. I'm going to do this from the bottom, which will be from the side because I'm going to have to stand this up on its side and then recap it. And then I will do this board, and I don't know what board this is. I'm thinking this is part of the power supply. This might be the protection, part of the protection circuit, but I'd have to look and see. But I'll do this board. Again, I'm going to do them off camera because all you're going to see is this thing sitting up on its side. But I will come back, let you know what I determined about the filter caps. If I ran into anything here, I don't believe any of these transistors are problem transistors, so I will be most likely leaving them in their positions. And these are just kind of all normal value caps. So anyway, I'm going to go on to do that. Oh, there's a service. There is a service sticker on it. I love seeing these. These are kind of cool. So Henco Electronics, Atlanta, Georgia, and it was serviced by someone with the initials RW on 11/6/1970. I think that's kind of cool. So anyway, on to recapping the board. Again, I'll just come back when I'm done. I do want to talk really briefly about these 1,000 microfarad cans or caps. 1,000 microfarad 50 volt can is negative. So I don't know if you've ever come across these. Positive, and then basically the outer ring is negative. So when you pull this out, you have to make sure that you get it aligned correctly. Luckily the board is marked with positive and negative, but you will have some extra holes in the PCB. So I'm going to test this just for the sake of testing one of these. I'm going to do the other one next. I decided I would do the pain in the butt capacitors first. Yeah, 1300, so that's way out of, I would assume this is less than 30%. It's supposed to be less than 30% in terms of tolerance. So anyway, just wanted to point that out while I'm working on this board. So I'll do the 2 big ones. Then I've got 1, 2, 3, 4 little ones. These transistors should be all right, so I'm going to leave them. And yeah, then I'll come back around and let you know if I found any more interesting things on this board. I'm going to pick it up soldering these, so you will see a little bit of work. I know some people like to see that. I found one open cap. There's 100 microfarad 16 volt in there. That, let me make sure I just didn't have it on the leads loose. Yeah, it's open. So there's one open cap in there, and everything was way out of tolerance. Like the 47s were about 70 microfarads. The 470 was 675. So they were all pretty bad. What I did is I took a little to get this board out of the way so I wouldn't burn any of these wires. I took some clips, right? Just kind of made a makeshift kind of a little thing to tie this off on. So that's why that looks like that. What I'll do is I'll finish putting these in, do this board. I'll speed through that stuff, and then we will turn it on, make sure everything is working, and wrap up the segment on these 2 boards here, and then we'll go on to the next one. But let me get this one done first. And that board is done. Boy, that last cap was kind of a pain. Hopefully you, when I speed through the footage, you cannot hear what I was saying, because I was saying it very quietly, but it was not very complimentary. And I don't want to have to go and bleep anything out. But that last one was a little tough. What I'm going to do is, once I get this board screwed back in place, I am going to test those caps, see what those were like. Talk about one of them in particular. It was kind of oriented. It's an axial cap oriented up and down. You know, just talk about that one just for a second. All right, so this is a 220 10 volt. Let's see how this one comes up. 390. 390. And we did not get a happy beep with that one. That's pretty high ESR. And we have another open one. This was 10 microfarad at 25. That one's open. And then the one that I want to talk about, this is supposed to be 10 as well, and this is 14, so this one's not horrible, but it's still outside of 40%. So what I wanted to kind of share with this cap is this, you know, you got to be careful. The caps can be deceiving. I would see this stripe and I would assume this is the negative side, but this is actually the positive side. And it's sat in there up and down like that. So anyway, power supply is done. I'm going to fire this thing up, test it off screen, assuming everything is fine, which it should be. If anything comes up, it's probably a cap that I have in incorrectly. But anyway, we'll pick it up with the next segment. I don't know what board I'm going to grab next, but we will talk about that in the next video. So as always, if you like what you see, hit like, hit subscribe, and I will catch you in the next one. Filter caps are in. I may have been saying these were 4100, they're 4700, so, or I may have been thinking when I was ordering these that they were 4100, but they're 4700. These are the same diameter, but they are, geez, almost 3 times shorter. Again, I had a hard time matching up caps that would be that size, which is kind of a bummer, but you know, it is what it is. So these would just be a little bit shorter. So what I'm going to do is first because these are snap-in caps, I am going to solder on a couple of these little posts that I have. So these little posts, I'm going to solder these into position like so on the caps. Make it easier to connect everything underneath. Let's see, negative black is what the caps say. So we'll have to see what that looks like underneath. Yep, so negative post has a little black rivet, I guess. A little black rivet. These were some bleeder resistors, I think. So what I'll do is I'm going to remove this one first, and then we'll work on this one. I will film as much of this as I can, or record as much of this as I can. I'll probably desolder the wires first, and then maybe I won't. Maybe I will loosen the cap first. That would make the most sense. And there's a bracket holding it in position. But what I'm going to do is just remove the screws holding the bracket in position. And then the cap will fall, and I'll remove the bracket. It'll be easier to remove that and put it on the new one. Alright. And I might as well do both. I got it turned right side up. And I ordered, well, I mean, you're watching this in kind of out of order, but you can see I've done some work to the amplifier board that is in the section that follows, or the segment that follows, the part of the video that follows this one. So basically I had to do another order to Mauser, so I'm waiting on parts to come in on that. Just in case you noticed that there was some work done to that board. Alright, so let's get to replacing these filter caps. Let me see if I can get this zoomed in just a little bit so you can see my work. There we go. Now I realize there's a whole bunch of that was done off camera. And if you can't tell by the tone of my voice, I hate filter capacitor replacements. Right? I don't like to replace them. They're a pain in the butt. Should be easier than it is, but it's not. So. Screw types are great. But these with, you know, you got to use a snap-in cap and you got to try to get, it's just a pain. So not my cleanest job ever, but should be good enough. Everything's secure. Just double checking everything. Yep, everything seems to be secure. So, but what I want to do before I call this segment good, which I hope to do here in a minute, is I would like to test these old filter caps and see exactly what was going on with them. I may have to do a little bit more work on those, clean those up. Again, You'll notice a trend with the gear that I worked on where I say I did everything but the filter caps, and that's why I don't like doing them. So. Alright, so these should be 4700. $55.19 on that one. And I measured them in circuit. I measured one at like 3 and one at 6. So, but that was in circuit, and that's not at all accurate. So, 6513. All right. So filter caps were out of tolerance as well. So what I'm going to do next is power this on, test it. If anything happens, I will include that in this segment, but I am hopefully justly confident that everything is fine, just a little ugly. All right, so this should conclude the power supply protection circuit filter cap replacement. I'm probably going to tack this on to the end of this stuff, so I may have already said this. If I did, I apologize, but as always, if you like what you see, hit like, hit subscribe, and I will catch you in the next video.